talked about this last week, reading graduated cylinders. So I want to make sure you know how to read different types of graduated cylinders. What we're going to do here is we'll work on one of these just so you can have practice determining the value of the grids, the minor grids versus the major grids. Okay? So at any points, if you have any questions or any comments, feel free to write it in, once again, the message box. So looking at the grids right here, in the graduated cylinder, it says here, determine the value of the minor grids on the cylinder. So you have 4 different images here of 4 different cylinders. I will start with A. The most important thing here is to start with the graduations that are numbered. So start with that first. And then once you're able to see the numbered graduations, then use that to estimate the ones that are not numbered. Okay? Let me see if I can zoom this a little bit more. Oops, okay. Okay, right here. It's a lot easier for me to see this way. Okay, so looking at this here, this bottom graduation here, or this mark, is marked as 0, right? And then this top one here is marked as 10. So I can see the value between the bottom graduation that's marked and the top graduation that's marked is 10. So I start with that and I figure out what is called the range. The range is how far out the major graduations are spaced. Okay. So in this case here, you can call it the increment also. Actually, the range is the whole thing. So this small part here is actually called the increment. Anyways, so from here to here is 10. To be specific, the increment or the difference here is going to be 10 minus 0, and that's the gap here, which is 10. Remember, for most graduations, in the graduated cylinder, these are written in milliliters. So technically, this is 10 milliliters. Okay? Now the question is, what is the value? Oh, you can't see where I'm pointing? Oh, snap. Okay. So you can't see anything I'm writing? When I scribble like this, can you see? Oh, you can see the writing. Okay. I wasn't using the pointer just yet. So let me go ahead and see if I can. Oh, it clears everything. Yeah. Can you see the pointer now? When I do this? Oh, no. Okay, I see. So what I'll do is I will mark what I'm looking at, since you can't see the pointer for whatever reason. Okay. I think maybe it's a computer or collaborate. So yeah, let me go ahead and mark as I am talking. Okay. Thank you for letting me know. So I'm looking at these 2 marks right here. This is the 0 mark, and this is the 10 mark right here. Okay. So once again, the difference between these 2 is 10 minus 0, and this is going to be 10 milliliters. For the most part in the lab, so now I'm not pointing at anything. For the most part in the lab, the graduated cylinders are measured in milliliters. Okay, so our goal right now is to figure out what these spaces right here, these little spaces, now I'm marking, hopefully you can see that, the spaces between the marked parts, what they are worth. For us to figure that out, we know we have 10 milliliters, but how many little spaces do we have between the 0 and the 10? So I'll go here and count, and let me use a different color to count. I will use green. Okay, so I'm counting the little spaces in here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 milliliters spread equally over 10 spaces, right? So that means that each of these tiny spaces in here is worth 1 milliliter. Essentially, it's 10 milliliter divided by 10 spaces, right? So each of those little spaces is 1 milliliter. That means between the 0 and the 10, halfway through, this is 5 milliliters. Okay? Milliliters. If you're asked to report, you will report accordingly. So all I did here was show you how to figure out these graduations, okay? So what I want to do right now is to have us actually read one of these. Now, let me pick one where the graduations are different from the ones we did. Let me do this one here, okay? So we're going to be reading the volume of the liquid in this graduated cylinder. So once again, let me see if I can zoom in a little bit more so we can see right here. Okay, so for this one here, again, let me mark. This is 20, right? And this right here is 30. So the gap between these two is 30 milliliters minus 20 milliliters. And that gives us what? 10 milliliters. So based on the space available, we have one. So now I'm just counting between the small spaces, okay? 1, 2, 3. So right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each of those spaces that we see here is actually we just have 10 spaces. So essentially, each of those spaces is worth 1 milliliter. I was trying to get a different question, but I got one very similar. It's okay. So that means that right here, halfway between these two is actually 25 milliliters, right? But they want you to read the actual value of this meniscus. When the liquid is bending on that mark, they want you to read the actual value. So for that part, I have to zoom in even further. Okay, so I'm zooming in further so I can see. So you want to look at this part right here. Here, it's hard to get my mouse right on that spot. Here and here. So based on the reading we have here, I currently have 25 oops. I'm about to estimate the next number right here. To figure out that number, I'm trying to look and see. This number, the liquid there is occupying, for me, it looks like about a quarter, right? A quarter of the available space. It's not really half. It's less than half. You can estimate a third or a quarter. What I'm going to do here, I'll say about, it looks more like 0.25, but I'll just say 0.3 to make it a lot easier. So I'll say 25.3 milliliters. Oh, that's a 3. It's difficult to write small in this mode here. 25.3 milliliters. Okay, so when it comes to the reading here, there is two numbers that are certain. That's the 2, 5. It is certain because it's actually on a mark. And then the one that I had to estimate is the 0.3 part. This part is the estimated part. Of course, the measurement here is milliliters. So I think one of your homework questions should have a question like this, where they're asking you either how many decimal places or how many significant figures. If they ask you a question, how many significant figures can you correctly read in this volume here, you would say 3. Okay, so while we're here, let me see if I can go ahead and read this next one. It's a little higher right here. For this next one here, our lower value is 35. Our top value is 40. So the difference here is what? 5 milliliters, right? 40 minus 35 is 5. So if you look at the space available to spread that 5 milliliters, we have 1, 2, 3, 4, 5. Just meaning that each of these spaces is worth 1 milliliter. Okay? So in this case here, our volume, the last mark that I can read that's actually marked right before I get to the meniscus is not 35, it's actually 36. So you see that right here, right? So this number here, or this mark, is 36 milliliters. So I write 36 milliliter, and then of course point. Oops, where's the point? There, it's hard to write the point. 36 point. Now I have to estimate what this value is. I can say it looks like right about either 5 or maybe 6, slightly above halfway. So then this is going to be 35. I'll say 0.6. I mean, sorry, 36.6 milliliters, right? So you want to make sure you go as far up as possible to the last number that you can identify that goes with the mark. So the last mark right before the meniscus, and then read the value of the mark based on what you estimated the increments to be. So it's important to find the increments first and then read that last mark right before the meniscus. And then after you read that, you add to the meniscus. Okay? Any questions about this? So let me go ahead, and this one here is different. Let me go ahead and see if I can read that one too. And then we'll continue with the other worksheet. Oops, I think I've zoomed in all the way. It won't allow me to zoom in anymore. So for this third one here, let's see. This is 5 and this is 6. So the difference between these two is 1 milliliter, right? So this time I have 1 milliliter, and 1 milliliter has to be spread over 1, 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 milliliter divided by 10 spaces. So if you take 1 divided by 10, essentially we have point. Oh, I'm struggling to write because I don't have enough space here. Okay, we essentially have 0.1. Okay, so each of those little spaces is 0.1. So starting from here, this is 5.1, 5.2, 5.3, 5.4. So when I'm reading this, the last marked point right before the meniscus, I see as 5 point. Come on. This is a little difficult. Okay, 0.4. Okay. Now I have to estimate the next decimal place right here. So I got this as 5.4. Now I have to estimate the next decimal place. When I'm looking at the space occupied in the space between 5.4 and 5.5, it looks like the meniscus is about halfway through. It looks like halfway through from where I'm standing. So that means it's a 0.05, right? Halfway through. So that would be that this is 5. So I'll estimate that to be 5. So reading at 5.45 milliliters. Okay. Does anybody have any questions about that? Look at your meniscus. Spend the time assigning the value of those little increments, right? So you know what their value is. For every space you move up, you want to add to your original last mark, right? So in this case, we moved up 4 spaces. So that makes it from 5, it will be 5 plus 0.4, so 5.4. And then you want to estimate the next number. Any questions about that? Okay. If you don't have any questions, this is all I have for this worksheet. Of course, the rest of these pretty much go through how to estimate the space. Same thing. Take the top number minus the bottom number. Take the number you have, divide it equally. Don't divide it by the number of lines. I used to do that as a student. And then I'll get confused because I feel like I was always missing one. You're dividing the big space into the small spaces, right? So when you do it that way, it works a lot better. Okay, let's go exploring. I say exploring because I don't use this feature a lot on Blackboard. So let me try to see if I can add the other content. It wasn't exactly allowing me to add the other. So give me just a moment. Then I'll go back to the regular PowerPoint, okay? Okay, my other document is ready here. Oh. Oh, it's allowing me to do it. Okay, good. My next file is uploading. Okay. It takes a while when it uploads to share with you. So, oh, I have to say share now. So let me go ahead and zoom out a little bit so we can see. Okay, so let me zoom out so y'all can see. Oh, it zoomed out completely. There. Okay, so for this one here, hopefully you can see what I'm writing. It says here, we're looking at elements, compounds, and mixtures. Okay, so it says here, classify each of the pictures below by placing the correct label in the blanks below. So we're placing the labels here in these blanks. Okay, we're going to be placing either element label. So we're going to look at the particulate level. By the way, these images are all particulate. So I think I'm going to ask you guys to write, because in my last class when I did this, I had you guys to write, okay? To write or to participate, you're going to click or activate the pencil feature, then pick a color, then you can write. So, but before we go through it, I want to make sure we define what is an element and what's a compound. So they say here, if you think it's an element, you can put A for element. If you think it's a compound, put B for compound. If you think it's a mixture of elements, put C. If it's a mixture of compounds, put D. If you have a mixture of elements and compounds, then you want to put E. So how do we identify what's an element and what's a compound? It says here, each circle represents an atom, and each different color represents a different kind of atom. If two atoms are touching, that means they're bonded together. Okay, so real quick, remember, elements are made up of atoms. So atoms make up elements. Okay, so you gotta have, when you look at the building block of elements, it's essentially atoms. Like cells make up eventually organs or different tissues in your body. The building block, the fundamental unit of the element is the atom. Okay. As far as the picture is concerned, as long as you have a single circle with one color, that will be an element. But this element is called monoatomic element because you only have one atom. Sometimes you have elements that are made up of atoms that are combined together. So we have monoatomic elements, and we also have what is called diatomic elements. Diatomic elements, these elements tend to exist in pairs in nature, bonded together. So how do you know something is an element, not a compound? Elements tend to be alike. The circles in the element are alike, so they'll have the same color and same size, and of course they all have the same shape, but they'll have the same color, same size. So the elements can be this form, the singular form, the monoatomic, or this form, the diatomic. It can also be triatomic or tetraatomic, okay, or it can have hundreds of atoms combined together. The thing is, as long as it's an element, the circles look exactly alike, okay? And they're the same color. If it's a compound, you can't have a compound with a single atom. The compound has to have two atoms or more, and then they have to be different. So the way they'll show it to you here is they'll have different colors. So this is a compound. All of these, oops. So I put C for compound. All of these here are elements, okay? So hopefully I have explained that. Okay, the rule of using this, I really haven't figured out how to clear. Yeah, I haven't figured out yet how to clear all these writings without clearing everything. If you happen to clear everything, just go back and then, write it again, okay? But I'm going to give you guys an opportunity right now to work together to mark this. So let me zoom this out a little bit. Okay. So you guys can mark it. So each person can pick, let's see. If you're going to do one, do every, since there's three of you, if you're going to do one, do every third, right? Like do one, do four, do like maybe the vertical row. How about that? The vertical column. Oh my goodness, I forgot English words. Do the vertical column, and then the second person can do the second one, and then I'll be here, of course, to kind of help you guys out. So you want to go through. Please write down the key so you know what is what. Okay. So while you guys are watching this, write the key down so you know what is what, and then go through and label this. So what I'm going to do to help out, I will do number one. Number one, I think based on the combination, this is a compound, so I will write B here. So feel free to work on 2, 3, 4, 5, 6, and whatever you can see. Okay. As you work on the top ones, I will scroll down so you guys can see the other ones. You can all write at the same time. You don't have to wait for anybody to start. Do you know how to write? Can y'all hear me? Oh, somebody's already writing. Okay, I see. My bad. You're there, right? Yeah, it takes a while to get the hang of writing with the mouse, right? So the rest of you can start writing the other ones, and when we get done, we'll go through together and make sure we got it. So this is one of those learning objectives that I want to make sure you really understand. We don't get a lot of practice questions in the homework or in the text. Okay. Okay, so 7 is A, right? Okay, thank you. And I see 2 is C, 5 is A. Okay, keep going. I mean, all I have is the 3 of you. So once you're done with one, work on a different one. I don't even know who is doing what. All I'm seeing is marks appearing. So we still have 3, 4, 6, 8, 9, 10, 11, 12 to be answered. Just in case you forgot, let me scroll up a little bit. Let me see. Can I scroll this out of the way? Oh, good. Okay. So C is mixture of elements. Okay. Yeah, A is element. B is compound. Okay, do y'all see any other ones? We still have a bunch to answer. We have 3, 4, 6, 8, at least on this view. So what I do sometimes when it's hard to see, when it's hard to really tell, I will write the letter above it. Like if I think it's the element and I think it's a compound, I'll write, element compound so I can see. Okay. So is number 3 E? Is that an E? It looks like it could be an F. I think it's an E, right? Okay. So I've had a little bit more practice writing with a mouse. Just a little bit more practice. Okay. We still got 4, 6, and 8. What do y'all think? Okay. And D is, I think that's D, right? For 4. Mixture of compounds. So far, 1, 2, 3 are correct. D, A. Looks good. What about number 6? So number 6. Is that a D as in dog? So when I look at these for number 6, they all look the same to me, right? Number 4, these are obviously different. So I can see how number 4 is a D. Number 6, I think these are all alike, right? So I'm thinking maybe B. Oh, don't press erase, just cross it out. So I'll say number 6 is probably a B, right? Because these are all the same. They're just oriented differently, but they're all pretty much the same, right? 2 circles in the middle, surrounded by 4 circles. So let me see. Number 7, A. all elements. Okay, somebody's working on 11 already. Number 8E, yeah, elements and compounds. Number 9C, what was C again? Mixture of elements. Yep. Okay, I don't even have that list memorized. Okay, number 11, B. Yes, number 11 is similar to number 6, right? So B. Okay, what about number 10? And after that, yeah, I think number 10 is the E. I agree. And then, so looks good so far. What about, we got 12 to 15. Yep. This one is a tricky one. You kind of have to look closely, right? But this is a compound, this is a compound, and they're different. Two black circles, one white circles, two white circles, one black circle. So you got a mixture of compounds, right? I think 15, you see, this is a compound, right? 15 is kind of like 12. This is a compound, and this is a compound too, but they're different compounds. So this looks more like a D, right? And yeah, this one here too is D, right? Compound and compound, but the arrangement is different. You have two black circles surrounded by four white circles, and then the reverse, right? Yeah, so these, I would say, yeah, that. So hopefully we've gotten some practice. Remember, we're looking for types, right? So what I'm gonna do here, let me use a different color to kind of show you. Let me use the red. With the ones that I had to cross out. See, this is a compound because it's a different color. And this is a compound because they're different color circles. But these compounds are not alike. For that reason, you select mixture of compound because it's two different compounds together, right? And then with this one here, they were all the same. They were all compound, compound, but they're equal to each other. That's why we went with B. So yeah, other than that, I think we did good. So now that we're done with this part here, let me see. My computer has gone to sleep. Let me go back to my iPad. Okay. Does anybody have any questions about the exercise we just completed? Okay, let me go ahead and share my screen. Okay. So you guys may not see my face, but this is recording. So let me go ahead and share my application, my screen, so y'all can see that. Okay. So here we are. This is where we left off last week. Can you see my screen, my iPad? Okay, thank you. So let us continue where we left off. We had talked about the operation rule. Ooh, where's my writing utensil? Right there. And so I think I wrote a note for myself where to stop. Okay, I see I skipped over the multiplication and division. So let me go ahead. Since we did this part here, I said start here. I actually have to do the multiply and divide first before we continue where I said start here. Okay, so a quick recap. Last week when we were working on significant figure calculations, we mentioned that when you're adding or subtracting, right here, in adding or subtracting, oops, significant figures, align decimal, and round answers to least decimal place. Okay, so we talked about this last week and we got a chance to work on this last week. Today we're going to be working on multiplication and division operation. With adding and subtracting, the decimal place, once we get the correct decimal place, we have the correct significant figures. Okay, so here the idea is the correct decimal place is the correct significant figures. With multiplying and dividing, we're not going to do a detour method. We're doing a more direct method. So here what we do is assign significant figures, round answers to correct significant figures. Okay, you're either rounding up or down until you get the correct significant figures. So in multiplying and dividing, that is a more direct method. In adding and subtracting, you're kind of detouring and looking at decimal place, but once you get the decimal place, you also have the right significant figures. Okay, so what I'm going to do here is, even though it's written out, I'm going to go ahead and do exactly what I wrote. I'll assign my significant figure so I can know how to round up or round down. At any point, if what I'm doing is not making sense, feel free to make a comment in the message box. That's what it's there for. Okay, so let me start with this. Remember the rules we covered last week. All non-zero numbers are significant. So this number right here has 3 significant figures, right? 3.56. All numbers, significant figures, they're significant. This number here has 1 significant figure because I only have 1 number, right? Don't add a decimal to it and try to change it. It is what it is. 3 sig figs, 1 sig fig. So I do my multiplication on the calculator and I get this, 14.20. But my answer can only be correct to 1 significant figure. So in this case here, you have to round to 1 significant figure. How do you do that? How do you figure out what is 1 significant figure? Do you count from the right or do you count from the left? You actually count from the left. Since we're only allowed to have 1 significant figure, the first number you run into is the only number that will remain. But how do you have that number remain without changing the magnitude, the value of the number? Not the specific numbers, but the value. This number is in the tens, as in it's 14. So the number 1 remains. So I'm going to write it here, 14.24. This number remains. This number drops off, and these numbers all drop off. Okay? But we are trying not to lose the value of the number. As I mean, when I say the value, I mean the magnitude. So you write it as the 1. Remember, the 1 number remains, and then the 4. Because 4 is less than 5, it gets converted to 0. And then you don't include these. Don't convert the 2 and the 4 to 0, 0, because if you do, remember, based on the rules we learned last week, that will actually be a number with 4 significant figures. You're supposed to write a number with 1 significant figure. So you erase these, and you're left with this. 10 centimeters square. Okay, if you write 1, that's not correct because 1 is so much less than 14. Okay, you want the number you finally end up with to be close to the number you started off with, not completely off. Okay, so just to kind of practice a little bit more of this, let me show you some other numbers. Let me give you some other examples that were not given here. Say you have 1572 3. Why not? And they tell you to round to one significant figure. Round to one significant figure. Once again, you start from the left. This number makes it 1. All the other numbers don't make it. But you see this next number? The next number is 5. So as long as the next number that doesn't make it is 5 or above, you round that 5 up to 1. So these are math rules. Honestly, I haven't done like just pure math in so many years, so I've forgotten the name of the rule. I just know this is rounding up. So since this number is 5 or above, you add a 1 to this. And so this number changes and it becomes 2. Now you can drop off the rest of these. And so this position here remains, it becomes 0. This position here becomes 0. This position here becomes 0 and then 0. So you see what happened? This used to be 1. This was 5, 7, 2, 3. All the positions are still there. They just all got rounded up to add a 1 to the first number. Okay? That's kind of how you would round that number up to get one significant figure. So let me show you one more. If you had 1, I don't know why I'm starting all the numbers with 1. Let me try a different number. If you had 5, 6, 5, 2, and they said round this to 2 significant figures. Okay, this time is 2 significant figures. So you're counting from the left. This number makes it. This number makes it. These two don't make it. Okay? So you're going to write 5. You're going to write 6. And then remember, for these two numbers here, you have to ask yourself, this first number you're about to cancel out, is it 5 or above? If it's 5 or above, then this last number, the number right before it, has to be increased by 1. Okay? So I go back here. I change this number. I put 7 here. And then this is now 0, 0. This is the same number in 2 significant figures. Okay? So hopefully I have explained it. I'm able to spend a little bit more time here because I do have one more day to finish this chapter. Okay? So hopefully you've seen how to convert numbers to one significant figure or, as needed. Okay, once we've seen that, now I want to go ahead and look at this right here. Okay, so over here we're told, we did this one already, right? One significant figure, that's done. Oh yeah, multiply these two numbers. Okay, significant figure rules. This is significant, significant. These are all significant, so I have 4 significant figures here. Here I have 2 significant figures. If you've forgotten the rules from last week, please go ahead and review that. So anyway, you see, my answer has to match the least significant figures. So when you multiply these two, your calculator gives you 10.25. This is 10.25 right here. Let me see. These are currently 4 significant figures that have to be rounded, round to 2 significant figures. Okay, so which numbers get to remain? Let me do a quick check. This remains, and then this remains. But how do you write it so it remains? There are 2 ways of writing it, okay? What they say here, since you want the 2 numbers to remain and to count as significant, to make a 0 significant, you can write it after the decimal like that. You can write it scientifically, okay? So to make the 0 here significant, either write it as 1.0 times 10 power 1, okay? Of course, we have the units that came with the question, milliliters, and that makes the 0 significant, and this counts as 2 significant figures. The other way that I saw my teacher do when I was in college, she added a decimal. To make this number here, this 0 count as significant, she will add a decimal right here, bam, and based on the rules, that 0 is now significant. So you can write it like this, or you can write it like this. Either one makes that 0 significant, And so both of these numbers have two significant figures. Okay, the goal is for you to manipulate the answer so it matches the rules that were put together by the scientists. That's the part, that's the chemistry part, the part that you're like, okay, what is this? And it takes a while to get the hang of doing this. So you want to do some practice. Even after we're done with the session and everything, make sure you practice this, okay? Okay, so this is my answer in two significant figures. Next one, I got 45.0 centimeters over 9 centimeters. So I'm going to write the numbers here. The top one here, 3 significant figure. Bottom one, 1 significant figure. So once you get your answer, you have to round to 1 significant figure, right? The smaller one rules. Okay. So you get your answer as 5.0. This is actually 2 significant figures. You want to convert this to 1 significant figure. Okay, just drop the 0. This is now 1 significant figure. Okay, drop the 0 and it solves your problem. Okay, this problem here, let me actually add a page to it so you can see it better. The way it's written right now is hard to see. So this is an example of a problem where they tell you convert feet to meters. Okay, so I'm writing the question they haven't written. Convert 4.5 feet to meters. Okay, so the question, if you have a problem you're solving, you tend to use significant figure of given number to determine significant figure of your answer. Don't use the conversion factor, okay? So since this one here has 2 significant figures, then your answer will have 2 significant figures. So based on this, answer will have 2 significant figures. Well, you're probably asking, right? Y'all not saying much, but so my husband, let me tell you something, right? He's trying to teach me about financial stuff. I like to learn. I love learning about certain things, right? So I'm really into the financial world and stuff like that. It's not really similar to science. It's similar in a way. It has trends. There's predictability. There's graph. There's chaos. There's drama. So I kind of like it. I'm trying to get into it, you know. But I'm the kind of person when I'm learning and he's trying to explain something, he hasn't even finished, and I have a lot of questions. So he's like, "Can I finish my sentence?" But I'm like, "But I barely understood the first word you said," you know. And so I had to tell him recently, this is how I learn, because sometimes I'll let him talk, and then he'll be done. He's like, "You understand? Did you get what I said?" I said, "No." So I'm the kind of learner who, while I'm learning, I'm really asking a lot of questions. So he's like, "Can you let me finish?" Or he will show me a video, and then the guy will be talking, and the guy hasn't even said much. It's been like 1 minute, and he said, "If you let the man finish, maybe he'll answer your question." And I'm like, "But while he's still talking, I'm still lost, you know?" So that was me. That was the kind of student I was, and that's still the person I am. The kind of person, when I'm learning things, I'm asking a lot of questions, right? So I bring this up to ask the question to myself, and I'll answer it. Why did I say do not use the conversion factor to figure out the significant figure of your answer? These conversion factors here are usually provided in a table, okay? So what if one student picks a certain set of numbers and then the other student picks a different number? If Since you can set up conversions differently, if one person uses a different set of conversion factor and the other person uses a different set, you will arrive at different numbers. Okay, the value of the number will be the same, but you have different significant figures. And so one of those things I learned in chemistry, you know, as I said, I was that one student in the class asking why, why, why. And the teacher would look at me like, is she serious? I'm like, yeah, I'm serious. Like, why are we having to use the given number versus the conversion factor? Because I think I really like this conversion factor. And I wasn't always given the answer I liked or the answer that kind of made it make sense. But with time, I realized chemists like to be on the same page, right? A lot of these rules are to make sure that there's consensus, like we all agree. That's the important in the world of chemistry. So if we all follow the same rules, we all arrive at the same answer, okay? So if you go with a given number, this first one, then everybody rounds their answer to two significant figures. Okay, now, we haven't done the conversions that much yet. I do have a worksheet somewhere here. See all the documents on my screen? I have a lot of documents, y'all. But anyway, once I'm just going to write this down so y'all can see 4.5 feet. So once we have our conversion, we'll put this here. 1 foot is 12 inches. And I'll show you guys how to do this stuff. And then 1 inch is 2.54 centimeters. So this is assuming I've already gone through and picked my conversion. 100 centimeters is 1 meter. So once I get my answer as 1.3716 meters, these are 1, 2, 3, 4, 5 significant figures, right? You have to round this down to 2. So this remains, but the next number that has to be cut off or dropped off is bigger than 5. So round up, and this becomes 1.4 meters. Okay, remember, we don't use these numbers right here to figure out the significant figures of your answer. We use the original given number, right? 2 sig figs, 2 sig figs. So hopefully that clears things up if you had questions. Okay, once again, if you have a question and you feel concerned that you're going to be rude and interrupt me, feel free to do it. I was and I still am that kind of student. I'm not even ashamed of it. My husband looked at me like, really? I said, this is who I am. You married me for better or for worse. So I know this is a for worse moment, but power through. He just looked at me and said, well, but you know what? In the end, I understood what he was saying, right? Wasn't that important? Yeah, so don't worry about asking me questions. But anyway, so we went over that so y'all can see that you report your answer as 1.4 meters. Okay, so we are finally at the start here. We're now practicing, right? We have gone over all the questions. We're now kind of reviewing the rules. So here's what was not mentioned before, since we have a little start here, direction. If you have a mix of operations, you want to use PEMDAS. I had to learn about PEMDAS because where I come from, I went to school in East Africa. They call it BODMAS. So we had the British education system versus the American. So it was called BODMAS. Have PEMDAS. I'm like, how do we flip some things up? So I'm going to stick with PEMDAS, right? Or something about your dear Aunt Sally. I don't know what she did. No, she did something. Anyway, parentheses, exponents, multiplication, division, addition, subtraction, right? That's how you go in that order from left to right. So when we do encounter the different operations, we follow that. Now, I want to go according to how your book does it. So what I'm going to do here is add a page, and then we'll work on this. So I'm going to be lazy and use some technology. I'm trying to be hip, y'all. I'm trying to be a little bit hip. So yeah, let me copy this, and put this right here. Okay. So this is our first one, right? So you see we have so many different operations here. So I'm going to do PEMDAS. So multiply comes before divide, right? So I'll do all the multiplying first, and then I'll go ahead and do the divide. So I guess I'll start with, it doesn't really matter at this point. I'll start with this. Okay. What I'm going to do, I'm going to follow the way your book does it, which is to keep track of the significant position versus rounding it up early. I have seen other books where they round it up early, but to stick with your book, I'm just going to stick with a significant position. So what I mean by that is this one here is 3 significant figures, right? This is 1, 2, 3, 4. 4 significant figures. This is 1, 2, 3, 4, 5. 5 significant figures. This is 1, 2, 3, 4, 5. 5 significant figures. Okay? So let me start with this. This is 1.10 times 0.5120. So I'm going to do this part first. I pull out my calculator, and I have 1.10 times 0.5120, and I end up with 0.5632. Since this was 3 significant figures and this is 4 significant figures, my answer has to be rounded up to this position right here. Okay, but I won't round it up just yet. I'll just recopy it. So I've done this part and this part. So 0.5632. Remember, it has to be rounded to this position right here. Then I multiply it by this next. 4.0015. This is 5 significant figures. Remember with this one here, we're looking at it like it was 3 significant figures. But I'm not rounding yet. I'm going to round when I'm finally done. Take that number, multiply it by 4.0015, then I get 2.2536. My answer, 1, 2, 3. Oh, again, 3 significant figures. I'm just going to write this number here, right? The number gets bigger, but I'm just going to leave that. Then my last one, so I'm done with this. My last number is going to be 2.2. I'm just taking the answer I have, 2.2536 divided by 3.4555. So this is 5 significant figures. This is 3 significant figures. This is also 3 significant figures. 3 significant figures. So this is the position I want. I take my number in my calculator, divide by 3.4555. Okay. Finally, without deleting anything, I write my answer as 0.6521, whatever. But I only need 3 significant figures. This number here is not significant, it's a leading 0. So this works, this works, this works, and my final answer is going to be 0.652, and that should be my final answer. 0.652. Okay? And this is going to be 3 significant figures. Now, you could have just multiplied and divide, and that works. But the process I'm showing you when it comes to the adding, subtracting, multiplying, when you have those kind of questions, your answers begin to fall apart, okay? So I'm just kind of keeping track of what the significant figure should be rounded to towards the end, okay? That was A. Yeah, that was just A. We're just getting started, y'all. Okay, now we're going to be working on B. Okay, B is a much bigger calculation. I'll put B right here. Yeah, that's B. Okay, the good thing about B, they already lined it up for us, right? They lined up our decimal for us, so we know the decimal. You got to add, and you got to subtract. Okay, so this is still PEMDAS, right? PEMDAS. Let me write this somewhere. PEMDAS. So we add first, and then we subtract. Okay, we can do that. So I'll put 0.355. Add this to here, plus 105, because that's the line of the decimal, right? 0.1. Okay, this is 3 decimal places. This is 1 decimal place. Therefore, the answer we get should be in 1 decimal place. Okay, so I'm just going to add with my calculator, y'all. After I do all these chemistry rules, I'm like, my brain is like, use your calculator. They invented that for a reason. You need a mental break there. So I add these two and I get 105.455, right? But my real answer is supposed to be rounded off to 1 decimal place. Okay? So at this point, I'm going to subtract. After I got that, subtract 100.5820. This is what? 4 decimal places? So between these two, my final answer has to match that. So it has to be 1 decimal place. Okay? So I'm going to take this minus that, the top number, which I still have on my calculator, minus the 100.5820, which is going to be 4.873. But this answer can only have one decimal place. That means only this number remains, not necessarily the number exactly the way it is, but only that position remains. Like, of course, this one here remains by default, but the numbers after decimal, only one remains. So since this number here is bigger than 5, I'll round that up. So it will add 1 to the 8. It will be 4.9. So my final answer will be 4.9. And this will be the correct number in one decimal place. Remember, decimal place is the number of numbers you have to the right of the decimal. Okay? Yeah, so we're doing some math here. I think they go ahead and work everything out. Oh, I added a lot of pages. They work everything out and show you how they got it here. Yeah, they do that. With this one here, it appears they did it more directly and they just kind of, rounded it off. You can do that too, that works. Let me work on the next one. The next one is part C. So I was trying to see how they worked it on the slides. With this one here, you can do it more directly, and just remember, this is 3 decimal places, this is 1 decimal place, this is 4 decimal places. Your answer has to have 1 decimal place. So if you do it directly, that works too. Okay. And then just round your number so you only have 1 number left over. So that works too. Okay, let me get the third number and I'll put it right here. Okay, the third question. Actually, let me copy these two, put them here. Okay, I'm only going to be working on the top one here, so I guess I should cut the bottom one. Or just cut the top one. I don't know what I'm doing. This is what I need. Copy that part. Okay. Yeah, I was trying not to go back too much. Now I'm like, what did I do? Okay. There. So with this one here, we have to do parentheses first. Okay, parentheses first. So we'll start with this number here, 452.6755. Okay, so 452. I'm starting here first, right? 452.6755. Let me adjust the height of my table a little bit. 452.6755 minus, let me put a decimal right here, 33452. Okay, I'm starting with the parentheses first based on PEMDAS. Calculator time. Okay, 452.6755 minus 452.33. Okay, my answer comes out as 0.3455. Okay, let's see. 1, 2, 3, 4. I had 4 decimal places here. 1, 2. I had 2 decimal places here. Based on the number of decimal places, my answer should only have 2 decimal places. There. Okay? So this is where I was telling you it's very important not to round off your number too early. So my answer should be rounded off to this point right here. 2 decimal places, right? So now I can go ahead and, yeah, I'm going to actually need this space here. I can go ahead and replace this number here with this number, 0.3455. Remembering this is where I have to round off to. I've done the parentheses. What comes next? Multiplication. I have to do this part here next. Okay? Multiplication, I have 4.562 times 3.998 870. This is 1, 2, 3, 4, 4 significant figures. 1, 2, 3, 4, 5, 6, 6 significant figures, right? Yeah. So here, whatever we get should be 4 significant figures, the smaller of the two. So let me write that out. 4.562 times 3.99870. Okay, this is 18.24294. I'm writing all the numbers here right now. Okay, but I remember this is only 4 significant figures, right? I'm supposed to round it up. So 1, 2, 3, 4. It's supposed to be rounded off to this part. But I don't want to round off yet because I want my answer to be very precise. So I'm going to copy in the place of this number here. I'm going to replace it with this number. 18.242069, and this goes to this position right here. So I'm going to write the number down here, okay, as I summarize my final step. 18.242094 is supposed to be rounded off to this point right here from the left, and I'm dividing that by 0.3455. This is the position right here. Okay, I still have my 18.24 on my calculator. I just press divide by 0.3455. Okay, remember this is 1, 2, 3, 4. This is 4 significant figures. 1, 2. This is 2 significant figures. So when I divide these two numbers, remember my answer should be the smaller of the two significant figures. My answer is a big number, 52.7990204. It continues on, but all I need is 2 significant figures. So counting from the left, this number makes it, this number makes it, the rest don't. So since this number is 0.7, round up by adding 1 here, and this becomes 53. Okay? Any questions about this? Okay, so once they through here, you see how they worked theirs out. They did all that stuff here. They get that. See how they keep track of the decimal place, right? So we're going to be working on the last one. The last one. The last one, I already have this posted right here. I'll question this. Again, we'll do PEMDAS. In PEMDAS, you start with parentheses first. So we'll start with this number here first. 14.84 times 0.55. Because it's multiplying, we go by significant figures. 1, 2, 3, 4. 4 significant figures. 1, 2. 2 significant figures. So before I get my answer, I can tell you it should be in 2 significant figures, right? Okay, then I multiply 14.84 times 0.55. I get 8.162. So this should be 2 significant figures. The first one and the second one make it. Okay, now I have 8.162 with the position right here minus 8.02. This is minus, right? Remember, for addition and subtraction, you have to line the decimal up. Okay, so I'm going to say 8.162 minus 8.02. Remember, this has to be rounded up to 1 decimal place or 2 significant figures, right? So it's 2 significant figures here, but when you're right here, it's 1 decimal place. I know that's the tricky part. That's the tricky part. It's 1 decimal place. So do your math. This one here has 2 decimal places. So your final answer should have 1 decimal place, because this has to be rounded to this number here, 1 number of a decimal. Take the top number minus the second number, 8.02, you get 0.142. Subtract this, but remember, your final answer has to be rounded off to 1 decimal place, so you end up with 0.1. Right? This drops off and that drops off. So once again, when you go through the PowerPoint, which now I have an extra slide, you see how they work it out, right? They keep track of the decimal spaces, and then you get to 0.1. Now you're probably asking, can I just go through and just multiply this and then subtract it without doing all that stuff? You can do that, but you want to know how to correctly round it off. So if you just put in your calculator one time, 14.84 minus 0.55 equal minus 8.02. Oh, did I do something wrong? Or supposed to be multiplied, my bad. 14.82 times 0.55 equal minus 8.02. I do get, if I do it directly, I do get 0.131. But then if you just go by the numbers written here, it'll be hard for you to remember exactly how to round it off, right? It'd be hard to remember how to round it off. So yeah, essentially when you multiply this, once again, you get this number right here. If you try to round this off too early and you say this is 8.1 and then subtract it with this, or 8.2, sorry, if you round this off right here to get two significant figures, 8.2 minus 8.02 gives you a very different number. This one here, if you round it like that, you end up with 0.18, and when you approximate that, you get 0.2. That's the issue with this part here, right? It's a little tricky, but once again, feel free to rewind the video to watch the process. Worst case scenario, you can round off as you go if you feel more comfortable with that. It will give you most of the answers correct, okay? So wait, let me see. Did we just work this out? This is a different set. Okay. So for this one again, let me make sure it's a different one. What I'm going to do this time, it is a different one from the first one we just did, right? Yeah, it does look different. Okay. So what I'm going to do this time around is once again work on these ones here. And I'm not going to work on all of them. I just want to work on a couple. I'll work on the first one, A, and then C. That's it. And then we'll continue. Okay? Because I want us to make progress. Okay, so let me take this one here. So I want to do this the more direct way, which is just significant figures. 1, 2, 3, 4, 5, 6. 6 significant figures. 1, 2, 3, 4. 4 significant figures. 1, 2, 3. 3 significant figures. 1, 2, 3. 3 significant figures. Your answer has to be in the least significant figures. 3 significant figures. So I'm going to put this directly in my calculator and then round up. 3.10007 times 9. In PIMDOS, I'm doing PIMDOS in my head. I'm multiplying first before I divide, right? So 3.10007 times 9.441 times 0.0301. And then I divide by 2.31. So I get 0.38136, and the number goes on. Only 3 of these numbers remain. So when I approximate this out, I end up with 0.381. Okay? So that's it for my first number. The second one I'm going to work on, as I said, I'm working on these ones real quick, just to show you the other way of working this out. Once again, I'm doing PIMDOS here, parentheses first. So I'll do this part first. Line this up because it's decimal. 1.223. Add these. So this time I'm going to round as I go, right? I have 2 decimal places, 3 decimal places. My answer will be rounded off to 2 decimal places. So I'm going to do it that way. 44.11 plus 1.223. I have 45.333. I'm actually going to round this up so it's 45.33. Okay, approximately. Since I've done this math here, I can actually replace this number with 45.33. Now I continue. I've done parentheses. What comes next? Multiply. I'm going to multiply these 2 numbers here so I can replace this number with what I get from multiplying. 2.5110 times 21.2. I get 53.23. So here I have 1, 2, 3, 4, 5 significant figures. I'm going to write this down here. 2.5110 times 21.20. I have 5 significant figures here, 4 significant figures. So my answer should be 4 significant figures. So it'll be 53.23. Okay. So I'm going to rewrite my numbers. So I have 53.23. Is that divide by 45.33. Okay, I have 4 significant figures. I have now 4 significant figures. My answer will be 4 significant figures. I take my number that's in my calculator, divide by 45.33, and I get 1.174. Yep, my final answer. Okay, so let me go ahead and continue and actually make progress in this. So now that we're done with that, we've worked on a bunch of that. We're now looking at other measurements in the lab. We have a measurement in the lab called density. This is a physical property and it's used to identify different liquids, different metals. Some metals are more dense, some metals are less dense. So density is one of those physical properties. And we're told here it's an intensive physical property. Intensive physical properties are independent of the amount of substance being measured. Because it's independent of the amount of substance being measured, say you have gold, right? And you have a little gold or a lot of gold, you will end up with the same number. Okay? So density value is the same regardless of the amount. So scientists can use the density to identify a metal. Okay, at some point they'll have us determine the identity of a metal from gold or platinum that someone gave his fiance. It's this whole story and this, I call it drama. It's not that much drama, but anyway, yeah, we will use density to identify the metal in a ring that was given to somebody during the engagement. This is not a real story. This is a story, I think it's a story that was made up by the author. Okay, so we are practicing density. We're told here mercury Hg has a density of 13.6 grams per centimeter cubed. What is the mass in grams for 95 milliliters of mercury? So in a question like this, they will have to tell you what the desired units is so you know how to write things out. Let me copy this. First of all, erase this, then copy this over to a new page. Then we can talk about this. There. Okay. When you have a question like this, and you're trying to set it up for dimension analysis, look at the numbers given to you and write them down. So we are given density 13.6. I like to write my fractions like fractions, grams over centimeter cubed, right? I wrote this number down. And then we're given volume. I know this is volume because it's milliliters, as 95 milliliters, okay? What is wanted? Wanted is mass in grams, okay? So once it is mass in grams, so let's go ahead and do this. Let's go ahead and work this out. When you have two givens, which one do you start with? By the way, for the sake of convenience, or not really convenience, the peace of mind, I like numbers to go with units. So since this number here, there's no number here, I'm going to add a 1 because the 1 doesn't really change the value. I haven't changed anything. I just put a 1 next to the centimeter cube, so it looks better, right? So we got 13.6 grams over 1 centimeter cube. They want us to get the mass in grams. So we're going to start with all these two numbers. If you look at the units here, this is more complex. This is simpler, right? So start with number that has simpler units. This helps you a lot. As a student, I used to get lost. Then eventually I figured out, oh, we are always starting with the number that has a simpler unit. Why didn't you say that, Teach? So people used to call me Teach, and I was like, really? Just Teach? Okay. So we start with the simpler of the two. We start with 95 milliliters. The way the conversion brackets work, as you're doing conversion or dimension analysis, whatever unit you start off with in the numerator position, the unit in the diagonal position opposite to it must be the same. So since we started off with milliliters, the number here, whatever it is, has to have a unit milliliters so they can cancel out. And the same will be true of the number we have here, and so on and so forth. Whatever unit we have here, it has to match diagonally. So I write my 95 milliliters. Now look at my other number. Do I have a milliliter there? No, I don't. So I have to convert. I was trying to see if my conversion factor was downloaded here. I don't see it. I see dimension analysis, graph, blah, 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 all this stuff. Okay. So here, I have a bunch of stuff on here, y'all. A bunch of stuff. Let me go back here and see. I'm almost done with today's lesson, but let me find out my conversion chart because that's necessary. By the way, please notice this is written here. It is posted. Even in chapter E, let me find the conversion chart. Oh, I don't see it here. The conversion chart, I think I have it posted in chapter 1, but we still need that. Is it here? There it is. The conversion table. We need that. So please make sure you print this out. There it is. Okay. So I need a conversion between the two volume units, the milliliter and centimeter cubed. So if you look at this conversion chart here, they tell you the type of measurement. Since I'm dealing with volume conversions, I'm going to scroll down here to volume. Can I draw on this? Yeah, right there. I'm looking for centimeter cubed and milliliter relationship. So when I look over here, look at this, y'all, right here. This is what I need, okay? That is what I need. Wait. Oh, this is what I'm looking for. Okay, that's what I need. So let me make the screen a little smaller so I can pull this back up. Okay, there. There. So I found my conversion. I needed 1 milliliter equal 1 centimeter cubed. Okay. So before I actually use density, I've used this number. That's done. Now I'm going to use this number. Remember, these have to match. So the 1 has to go down here, right? This part. Top part is going to be 1 centimeter cubed. I just use this whole thing. You use the equality as a conversion factor. Let me move this out of the way since I'm writing right here. Or I could put it there. There. Okay, next, I'm going to write my density, which is already in fractional mode, as a fraction. Remember the rule. The unit I have here has to match diagonally in the bottom. So I'll write the bottom part of the density down here, 1 centimeter cubed, top part up here, 13.6 grams. Okay, so why did we go through all this stuff? Why not just use the formula that we have from physics? Because dimensional analysis is a skill that allows you to solve more complex problems, and you'll see this down the road. Okay? Milliliter and milliliter cancel out because we deliberately put them in those positions so they can cancel out. Centimeter cube cancels out. Now your wanted unit is the only one that remains in the numerator position. So now all I have to do is math. I know the number I get here will be some gram. I'm going to take 95 times 1 times 13.6. I guess divide by 1. Let's do this and see what happens. 95 times 1 times 13.6. Okay, 1292. Okay, we can't write the number like that. We have to figure out, do we have to round it up or down? Let's go through and see. We're given two numbers, right? This is 2 sig figs. We were also given this number here. This one, 3 sig figs. So since we have two numbers, the least sig fig determines the sig figs on our answer. So answer has to be 2 sig figs. So how do I make this 2? Remember, the 1 remains, this position here remains. So these have to go off. Since the next number, 9, is bigger than 5, I'm going to report this as 1300 grams. This is the same number in 2 sig figs. Any questions about that? Now I think they may have done scientific notation, and they may have done like 1.3 times 10 power 3 grams, but it's the same thing. Okay? Yeah, you see how they did it? But remember, in the end, since you have 3 sig figs here, 2 sig figs, your answer, this position remains, round these two off, and that's how you get your answer. Okay? You can write either one in the homework. When you start working on the homework, you see how it works out. Now they're telling you here, remember the chart I showed you, the chart or the table with all those conversions? They're telling you, once you see those tables with the conversions like this, you can use those equalities, they're technically called equalities, as a conversion factor. It's a tool, a means to an end. Okay? You can use that as a fraction, either in this form or in this form. And we'll get a chance to really convert those equalities into conversion factors to help us go from one unit to the other. Okay? When you're given a question, sort out the information. Figure out what's given, right? Write it down. Mark the simpler one because you're starting with that. And then figure out what's wanted, because it's important to have the wanted unit so you know when to stop. Okay? Let me see. I'm trying to do better this time and not go over with time, right? Not like I did last week. Devise strategy, solve problem, and then check your answer. So the general form that we're doing right now is given unit, use your conversion factor, and then you get your wanted unit. So what I'm going to do here is, since it's time, it's pretty much time, I'll write for myself, start here. So when we meet on Wednesday, we will start here with this new problem. Please make sure you have your conversion charts. I'll say conversion chart just in case. Ooh, chart. All of a sudden I can't spell. Conversion chart. Okay. Please bring your conversion chart. When I say bring it, like we're not physically meeting. I'm sorry. Oh, I'm just missing class. I'm missing face-to-face. But have that with you so you can keep referring to it. It makes it easier for you, right, to refer to it. I usually just print one out and have it with me all the time. Okay.